Problem number 3, find the volume of the solid formed by revolving the region between the curve y equals x squared, the x-axis, and the vertical line x equals 2 about the x-axis. So this looks like it might actually be 2 curves, but in fact it's only 1 curve. We've got y equals x squared, which is our function right there. We've got the x-axis, which is already down there, and then we've got the vertical line y equals 2, which is right here, or the vertical line x equals 2. So we're looking at this region right there. And it's going around the x-axis. It's a regular disk method problem, if you will. There's only 1 curve, and it's x squared. So our volume will be equal to pi times the integral from 0, where it begins, to 2. And our function is just x squared. So it's x squared being squared dx. Now x squared squared is obviously x to the 4th, so we have pi times the integral from 0 to 2 of x to the 4th dx. And that will become x to the 5th over 5 when we antiderive it. We still have our pi out front, and this is being evaluated from 0 to 2. Now when we plug 2 in for x, we have 2 to the 5th. 2 to the 5th is 32, so we have pi times 32 over 5 minus, when we plug in 0, 0 to the 5th is just 0. So there's our answer. We can also write it as 32 pi over 5. For problem number 4, now we have 2 curves, x squared and x cubed. Okay, so for starters we need to find our bounds. Those are not given to us. The way we find our bounds is we set the 2 functions equal to each other. So we have x cubed is equal to x squared. And if we move them over to the same side, we subtract x squared from both sides. We have x cubed minus x squared is equal to 0. We can now factor out an x squared, leaving us with x minus 1 equals 0. And using our zero product law, we know that x is either going to be 0 or 1. So those are our bounds, 0 to 1. We're going to have pi out front, but we now need to know which function goes first. So we've got to pick a number between 0 and 1. Let's go with a half. And we're going to plug them in to both functions. So we look at 1/2 squared, that's 1/2 times 1/2, or 1/4. And we look at 1/2 cubed, that's 1/2 times 1/2 times 1/2, or 1 cubed over 2 cubed, or 1/8, which is less than a quarter. So therefore a quarter, which corresponds with x squared, that function will go first. So we got x squared being squared, and x cubed being squared, and the whole thing gets a dx. We're now ready to do our work. It says show the work that leads to your solution, and you can check it on the graphing calculator. So here we go. We got pi out front, the integral from 0 to 1, x squared squared is x to the 4th, x cubed squared is x to the 6th, and that's wrapped and given a dx. Now we antiderive. Pi, x to the 4th becomes x to the 5th over 5, x to the 6th becomes x to the 7th over 7, and that's being evaluated from our 2 best friends, 0 to 1. When we plug in 1, we get a 5th minus a 7th. When we plug in 0, we get 0. So we don't really even need that part. So this is a good answer right here. If we were to simplify this, we have a common denominator of 35. So this is pi times 7 over 35 minus 5 over 35, which would be 2/35. So we have 2 pi over 35 as our final answer. And now we have problem number 5. Which says write the integral, which would find the volume of the solid formed by the region between these 2 curves, and we're revolving it around the x-axis. Use a calculator to find the bounds, and then to solve the integral. So let's do that. So there's our 2 functions, root x plus 1 and x squared. We need to find our bounds. Take a look at the graph. And we can see our 2 spots, one when x is negative, one when x is positive. So we're going to do our intersect command. So that's second trace, option 5. Enter in the first curve, enter in the second curve. And I'll type in negative 0.5 as a possibility. Turns out it's negative 0.72449. So A is equal to negative 0.72449. We now need B. B is located just after 1, so we're going to repeat our intersect command. So that's option 5. First curve, second curve. I'm just going to pick 1. That's pretty close to our bound. In fact, it's 1.22074. So 1.22074. So there are our 2 bounds. And now we can go to write our integral. So we have the integral with pi out front, our volume equals. A is our low bound, B is our upper bound. And I'm bringing the graph back for a second. Square root graphs are the ones that are only positive. That's our blue line. So the square root serves as our greater function, and the parabola, our x squared, is our smaller function. So we're going to have the square root function first. So the square root of x plus 1 wrapped in squared first, and x squared wrapped in squared second, and the whole thing receives a dx. So now we bring in our calculator to let it do the work. We're going to go to the main screen, and we need math. Actually, we need pi first. So second exponent gives us a pi, and then math 9, and we have negative 0.72449, and that's going to go till 1.22074. And if I go to y equals real quick, I see that the square root of x plus 1 is in my y1. So back here, I'm going to have alpha trace y1 squared first minus, and now alpha trace y2 squared second dx. Let the machine do all the work. We see 5.7987. So there's our answer, 5.798.